Eighth grade, welcome to week 13. We're talking about wave properties all this week, so hang on because it's going to be a ride. Today, we need to be able to understand the concept of amplitude. On a windy day, air particles move these flags and transfer their energy of motion to the particles of fabric. The energy travels through the fabric in waves. You can see the waves rippling through the brightly colored cloth. The windier the day is, the more vigorous the flags wave. Waves that travel through matter, such as the fabric of a flag, are called mechanical waves. The matter that travels through is called the medium. When the energy of the wave passes through the medium, particles of the medium move. The more energy the wave has, the farther the particles of the medium move. The distance the particles move is measured by the wave's amplitude. So, what is amplitude? Amplitude is the maximum distance the particles of the medium move from their resting positions when a wave passes through. The resting position of a particle of the medium is where the particle would be in the absence of a wave. We see here two different types of waves, transverse and longitudinal. In a transverse wave, particles of the medium move up and down and at right angles to the direction of the wave. Wave amplitude of a transverse wave is the distance between the height of the crest and the resting position. The crest is the highest point the particles of the medium reach. The higher the crests are, the greater the amplitude of the wave. In longitudinal waves, particles of the medium move back and forth in the same direction as the wave. Wave amplitude of a longitudinal wave is the distance between particles of the medium, where it is compressed by the wave. The closer together the particles are, the greater the amplitude of the wave. What do you think determines a wave's amplitude? Take a moment and think about this for a second. Pause the video, and then we'll come right back with the answer. You already know? Awesome, welcome back. A wave's amplitude is determined by the energy of the disturbance that causes the wave. That means the greater the amplitude, the greater the energy, and vice versa. The greater the energy, the greater the amplitude. A wave caused by a disturbance with more energy has greater amplitude. Imagine dropping a small pebble into a pond of still water. Tiny ripples will move out from the disturbance in concentric circles. The ripples are low amplitude waves with very little energy. Now, imagine an asteroid hitting the ocean. Very large waves will be generated by this disturbance. These waves are high amplitude waves and have a great deal of energy. So, in summary, wave amplitude is the maximum distance the particles of the medium move from their resting positions when a wave passes through. Wave amplitude of a transverse wave is the difference in height between the crest and the resting position. The wave amplitude of a longitudinal wave is the distance between particles of the medium where it is compressed by the wave. Wave amplitude is determined by the energy of the disturbance that causes the wave. A wave caused by a disturbance with more energy has a greater amplitude. So at this time, if you could explain amplitude to me, feel free to move on to the other activities. Otherwise, go back to the video and review. Have a great day.